Hi students, in this video we will discuss one BSc 6th semester practical, that is Planck constant. Okay, this is the Planck constant apparatus. Okay, using this apparatus, what we are doing? Okay, we will see the once experiment what is there. Okay, now see here Planck constant is there, name of the experiment, and aim is to determine Planck constant H by photocell, and apparatus required are vacuum tube, light source, color filter, Planck constant apparatus, etc. And principle is there, photoelectric emission we are using, and formulas are there. Frequency we can calculate nu equal to c divided by lambda. Now see c is speed of light in vacuum, that is 3 into 10 raised to 8 meter per second, and E also we can use in lastly. E value is 1.6 into 10 raised to minus 19 coulombs are there. Now see here V naught is stopping potential. V naught equal to Vb minus Vr is there, means stopping potential of the blue filter minus red filter. Similarly frequency is there, nu naught is there. Okay, this is also same thing, frequency of the blue color minus frequency of the red color. Okay, here Vb is there. Vb means stopping potential of blue color, Vr means stopping potential of red color, nu b means frequency of blue color, and nu r means frequency of red color. Now see, this is the circuit diagram. Okay, in this case voltmeter is there and ammeter is there, and this voltmeter and ammeter is connected to photocell. Okay, this side where variable voltmeter is there. Okay, now we'll see that one. Okay, now see what are the procedure means. Okay, in doing experiment we will discuss procedure simultaneously, but here procedure is there. Make the connections as per diagram. Okay, all these things are there, you read once or two times. Okay, now see this is the complete procedure. Okay, now see this is the tabular column. Okay, in this case colors are there, color filters are there, and wavelength is given, or otherwise you remember the corresponding filter wavelength, and nu equal to c by lambda. C means 3 into 10 raised to 8 and wavelength is here, and dividing these two you will get frequency. Okay, what in this experiment only we are seeing the microammeter reading and stopping potential of corresponding filter. Okay, in this experiment first color is blue, and green, orange is there, and red is there, and this is the calculation part. And finally after calculating this one, what we are getting this type of results. Okay, actually 10 raised to minus 34 is there, Planck constant is 6.62 into 10 raised to minus 34 joule second is there. Okay, now see this is the result, Planck constant is verified. After this verification, similar we have one graph. Okay, this is the graph. Okay, here one side we are using stopping potential and another side is frequency. Okay, x-axis frequency is there and y-axis stopping potential is there. We will get this straight line graph, this type of graph we are getting, and slope of this graph will give the stopping potential, right? Okay, now see, I will see the experiment, how it will be connected and how readings will be taken, right? Okay, now see, this is the Planck constant. Now see here microammeter reading is there. This is the microammeter reading, and this side is voltmeter reading are there. Okay, now see output of now connections are very simple. Minus of this microammeter is connected to positive of the slit here, right? Okay, this side I am connecting. Okay, now see it is common here, this plus and this plus is common here. Now see voltmeter and a microammeter, plus and plus is common here. Now see output of the voltmeter is connected to another end of this slit. Okay, now see this is the slit. Here we can put the filters here, at this place we can put the filters, right? Now see this is the Planck constant apparatus, and this one is the slit, and this is the source. Okay, here we are using light source here. This is the light source. Now the connections are completed. Now see this light source is connected to, here it is there, this light source is connected to the main, and one more is there, this Planck constant apparatus is also connected to this one. Okay, now see we'll start the experiment, first one. Okay, now see switching on this one. Okay, here source will be, light source is on. Okay, now see we will keep the sufficient distance between this slit and source, because sufficient amount of light is fall on the slit, then only emission will takes place, otherwise no emission. Okay, now see we will see the filters where they are. Okay, this side inside I put the Okay, this side I have kept here. Okay, now see, these are the filters. Okay, now see this. Now see, this is the red one. This is the red filter, red color, and this is orange. Orange is there, and this one is the blue color is there, and this is the green color is there. Okay, how we will do this experiment? Okay, in our table, what is there? In our table, first color is blue is there. Okay, now see, we will take the blue color. Now, which one is here? Okay, now see, this is the blue color. Okay, now see what I am doing here. I am doing this blue color is placing inside the slit, right? Okay, similarly I am switching on this one. Okay, now see what is happening here. The current light source, this light is falling on the slit, right? Okay, wait for 2 to 3 minutes after placing this slit and switching on the light source. Wait for 2 to 3 minutes. Now what is happening in micrometer or voltmeter? Now see here, we are getting some readings. Now this variable voltmeter, this is the variable voltmeter. I am keeping this 0, right? Now I am making this one 0 voltmeter. Now see, voltmeter is 0.002 is there. So still it is not 0. Okay, I am making this 0. Now see, 0.0032. Okay, 1 is there, right? Okay, same thing here. Micrometer reading is 1.46 is there. Okay, now after waiting for 2 to 3 minutes, next step is, okay, we'll take the reading. Now see, gradually here, micrometer readings is minus 1.45 is there, and voltmeter reading is almost 0 is there. Now I am what doing? I am slowly increasing this voltage. Okay, what will happen in micrometer reading becomes 0? Slowly or gradually I am increasing the voltage. Now what is happening is here. Okay, same thing what is happening here. Micrometer is 0, but voltmeter is gaining, means it. Now see, almost we reached here in micrometer. Now see, this is 0 0 almost, right? 0 0. 0.01 is there. I am making again slightly 0.000. Now see, corresponding voltmeter reading is how much? 0.771 is there. Okay, now see, similarly in our experiment I am writing here. See, micrometer reading is 0 and stopping potential is 0.997 is there, but in our case how much it is? 0.772 is there, right? Okay, this is the first reading. Okay, now slowly I am decreasing this one. I am making this 0 again, and okay, I will switch off these buttons. I will change the filter. Okay, now I am changing the filter here. Okay, because first one is blue is there. Okay, blue color is completed. Okay, next I am doing, which color is there in our table? In our table green color is there. I am taking green color, right? Okay, this is the green color. Again green color is putting in slit, right? Okay, same thing I am doing the experiment, similar experiment I am doing. Again I am doing this one, switching on this one. Now see, sufficient amount of light is falling on the green filter. Now wait for 2 to 3 minutes and corresponding readings are taken in here. Now see, this is voltmeter. Again it is 0 0. Initially voltmeter is 0 and final when you are getting reading means micrometer reading will be 0, right? Okay, now see, this is 0. 0.004 is there. Okay, after waiting for 2 to 3 minutes, so that becomes completely 0. Okay. See here, after waiting for 2 to 3 minutes, or sorry, 1 minute, within a 1 minute or within a 1 minute, now voltmeter becomes 0.01 is there. It is better to make the 0. Okay, now see, it is not making 0. Let's see here, micrometer, corresponding micrometer reading is minus 0.64 is there. Now I am gradually increasing the voltage. Now what is happens? Now see here, in micrometer what will happens? Now I am changing this voltage, gradually I am increasing. Now see, micrometer is decreasing. Now see, after reaching 0, we will stop there. Okay, now see, it becomes 0.000. Now see what corresponding voltmeter reading is 5.31. Okay, similarly I am writing for green color. Okay, wavelength is given and frequency you can calculate C by lambda, and micrometer reading is 0 and corresponding stopping potential is this reading is different, but in our case what we are getting? In our case we are getting 5.31. Okay, now see students, similarly we can do for orange and red. and finally calculation part will be there and graph will be there, right? Okay, this is all about Planck constant experiment. I think this experiment is very simple. Thank you for watching this video.